Hey guys, today we're going to start a new unit. We're going to be talking about covalent bonding, so I hope you're ready. So let's just review ionic bonding. We had two ions, right? One ion tended to be a metal or have a positive charge. One ion tended to be negative or a non-metal. In covalent, how it's going to be different is that we're working with two different non-metals, and sometimes more, but usually it's just two. So ionic are things that dissolve in water. Covalent tend to not. They tend to be nonpolar, which means they don't dissolve in water. Ionic tend to be like crystals. Covalent tends to be really anything. They can be gases, they can be liquids, they can be solids. Ionic things tend to have a high boiling point. Since covalent things can really be anything, their melting point seems to be pretty low, and their boiling point also is pretty low. So what I hope you notice here, most important thing you want to write down, covalent are non-metals only. Kind of cool. So normally we have to look at two charges and we have to compare them, and then from that we get a name. With covalent compounds, it's not at all like that. We get things like carbon dioxide, and some of them have weird names like hydrogen peroxide and water, for example, and methane. Those aren't scientific names. Those are kind of just common names. We'll tell you how to name those scientifically a little bit later in class. It's going to be very fun. So other things you need to know about in terms of properties, they have low melting points, low boiling points. They can be pretty much anything at room temperature. There's a lot of variation. They don't conduct electricity, and they have a weaker bond than ionic. Pretty much all of these are the opposite of what was true for ionic bonding. So when you think of an ionic bond, you tend to think of like a crystal that kind of looks like a salt. When you're thinking of a covalent bond, think of the opposite of that, so like a liquid or a gas, or like an oily solid, something like that tends to be covalent compounds. Okay, let's get into kind of the more important stuff for today, kind of how these happen, right? Okay, so here in the center of the little blue thing, we've got a positively charged nucleus, and all around the outside is our electron cloud. You'll notice that I've kind of put circles around the edges of the electron cloud, and in the middle here, we have these two electron clouds of these two atoms overlapping. That's a covalent bond. So the idea is that while this electron cloud is overlapping, the covalent bonds are sharing electrons. And we'll talk a little bit more exactly how we know they're sharing electrons and exactly how many electrons they're sharing. It comes from, technically it's an overlap of orbitals. In our class, how we'll kind of look at it is we'll look at it just by saying how many valence electrons does each have, and then kind of the idea here is that the atoms are bound together once they share two electrons. So one electron from one atom, the other electron from the other atom, they share those two, and that's where we get a covalent bond from. And kind of the idea is each atom shares until it has 8 valence electrons. So if we look at an atom like nitrogen, nitrogen has 5 valence electrons. And remember, you can find that just by looking at the column that it's in. Everything in column 1 has 1 valence electron, column 2 has 2. We skip kind of the middle part, and then 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. So nitrogen, we said, had 5 because it's in column 15. So looking at that then, you would say, okay, it needs to form 3 different bonds. And so we'll see that nitrogen will either bond with 3 different things, it'll form a single bond, and then 2 double bond, or 1 double bond, and a bunch of other things. It could also form a triple bond. So we'll talk more about that in due time. But for now, know that covalent bond is all about sharing. And I'll show you a little picture here. Okay, so here's 2 fluorine molecules. I've represented them with an F. What I'm now going to do is I'm going to show you the valence electrons. These are the little dots here. You'll notice that there's 7 dots around each F because fluorine has 7 valence electrons. So when you see these dots, you can just think of them as little electrons. I put VE down at the bottom because VE stands for valence electrons. In case you're wondering what is valence electrons, those are your outermost. So fluorine, I think, has a total of 9 electrons. There's 2 that are kind of inner. When it comes to bonding, we're only worried about the electrons on the outside, and we represent those with dots. Usually the dots would be much smaller, but I wanted to put those little electrons in there because they look so cute. Okay, each fluorine has 7 valence electrons, 7 dots. Now, what I'm going to show you is how they share them. You ready for this? Remember, the goal is to get 8. Right now they both have 7, so they're unstable. But if we move them closer, they want to get those 8 electrons. They're so close. Bam. See, now they have 8. We've got 2, 4, 6, 8. And 2, 4, 6, 8 for the other fluorine. So even though we only have a total of 14 electrons, total valence electrons, because they're sharing these two, this fluorine on the left acts like it has 8, and this fluorine on the right also acts like it has 8. So by sharing, they can do together what neither one of them could do alone, which is have 8 valence electrons, and as you see down here, they're now stable, because 8 valence electrons means stability. What you'll notice here is that each fluorine is sharing 1 valence electron, and this little blue circle is just highlighting to show you that these 2 electrons are what we would consider a covalent bond. However, it's not how we would draw a covalent bond. Instead, we kind of put a line in between these 2 atoms, and then we get rid of the dots here. So you take 2 dots, you kind of erase them, and then you draw a line in their place. So a covalent bond is drawn as a line between 2 atoms. The other thing to note is that a covalent bond is always 2 shared electrons. So what that means is anytime you see a line, think 2 dots. Sound good? Cool. Okay. Now, we're going to come back to that, to drawing structures. This is called Lewis dot structures, which we're going to do a lot of. It's kind of fun because some of the problems become like a little puzzle. What I wanted to spend the next little bit of time talking is talking about how to name stuff. So we're going to name this example SO2. Covalent compounds are a little different because we don't have ions, and that makes them a little bit nicer to name. So I'm going to turn this S into red, this O into blue, and this 2 into purple. The S, the O, and the purple 2 all contribute to the name. Here we go. What you do with the first letter, the letter in red here, is you just name it. So S is sulfur, so we put sulfur down. Pretty straightforward. With the blue letter, the second letter in this case is O. You name that like you would a nonmetal in an ionic compound. So normally it would be oxygen, but since it's the second one, instead of calling it sulfur oxygen, we would call it sulfur oxide. So that's what this is saying. The second is named like an ionic anion. Remember, anions are the nonmetals, the negative charge, that sort of thing. So oxygen changed to oxide, sulfur oxide. And then this 2 comes into play. Instead of calling it just sulfur oxide, we call it sulfur dioxide. The number here is, it says denoted by a Greek prefix. So Greek prefixes are like mono, di, tri, tetra, so on and so forth. So we're going to put sulfur dioxide. Since this S doesn't have a number next to it, the number is 1. And if the first element has a 1, you do not add mono. So first letter is, or 1 is mono. If you're not sure what the Greek prefixes are, I'll show you them on the next slide, so get ready for that. So that's one other rule you have to keep in mind. All the time students will mess up on that. And then the last rule is if an element starts with the same vowel as the prefix, you do not add an extra vowel. So instead of saying like 1 is mono, for example, so instead of saying monooxide, if I had 1 oxygen, I would just say monoxide. Kind of like how you don't say carbon monoxide, you say carbon monoxide, if that makes sense. Cool. Okay, so these are the naming rules. I would write them down in a way that makes sense to you. This is how they make sense to me. It's kind of a lot, but there are kind of 5 things you have to keep in mind for every problem. But that's it. There's no exceptions, no nothing like that. kind of 4 and 5 are the two exceptions. So if you know the first 3 rules, that'll take care of 90% of it. And then 4 and 5 talk about 2 kind of exceptions to the rule. Cool. If you have that written down, let's move on to the next slide. Here we go. Here are the prefixes. I would have these written. They're also in the back on the ion list on your periodic table. So you don't have to necessarily have these memorized. But you should know, for example, like pentagon, hexagon, heptagon, octagon, nonagon, and decagon. So the same things that we use in math for shapes or polygons, we also use in covalent bond naming. So triangle, tetrahedral or tetrahedron, pentagon, that sort of thing. So if you just really have to know mono, di, and tri. Notice that it's not bi. Bi is Latin, or maybe it's Greek. I don't know. One of the two. Di is the other one. So in this case, we use di for di. Okay, here we're going to name these. So why don't you go ahead and take a moment to try and name them for yourself, and then we'll go over them. Notice that I included the ones here just to kind of help you out, hopefully not to confuse you. Okay, first one is C1O2. You would know this as carbon dioxide, and that's exactly how we're going to name it. We name the first letter just how its name is, so we get carbon. And then since we have 2 oxygens, we say dioxide. This one, we have hydrogen, and we have 2 of them, so it would be dihydrogen. And then we have 1 oxygen. Oxygen is oxide, but then since we have 1, we put mono, but it's not monoxide, it's not monoxide, it's just monoxide. Great. Hopefully you guys learned something. Thank you so much for tuning in, and have a great rest of your day.